Yesterday, and a little bit the day before, we were chatting about sine and cosine graphs. Well, there are graphs for all 6 trig functions, but they have some distinct connections to them, especially when we get to the cosecant and the secant part. But we're going to start today with tangent because it, shockingly, is a connection to the unit circle again. Now, here's the thing with this. We'll do what we've been doing, except now, when I'm making my degree measures around the outside, I'm going to just keep doing everything in radians because that's how we've been graphing. We're not doing it in degrees. So instead of 90, we'll chat pi over 2. Instead of 180, we'll chat pi. Instead of 270, we'll chat 3 pi over 2. And we'll wrap it up with 2 pi back at the beginning. Bless you. And so if I even went as simple, because this isn't quite as easy as when we were doing all the stuff before with sine and cosine. I mean, I could take those values and divide them if I wanted to go that route, but I'm going to try and speed this up a little bit to give you all some more time here with stuff. So here's what I'll do instead. If you were to go through on your own and do sine divided by cosine for all of these, all the way around, because that's what tangent is, here's what the result would be as you moved your way around the unit circle. And this is going to kind of give us our guidance for how this is going to work. So you'd end up with tangent values of 0, undefined, 0, undefined, and 0. You're like, okay, now that's weird. So like we don't even get to 1? No. This is where tangent gets a little bit weird. So you're like, well, what in the heck is that going to look like? You know, I'm not doing a curve then. There is a curve to this. It's just going to be a little bit different and look like something that we've already done. So, a couple of tips to know on tangent. One cycle occurs between negative pi over 2 and pi over 2. Now, if you think about that distance-wise, from negative to positive pi over 2, that means the period for tangent is pi, not 2 pi. Okay, tangent's the only one that changes this up at all. But knowing that one cycle normally happens between these two is important to know because you're about to see something kind of weird. There's vertical asymptotes at the end of each cycle. Asymptotes at pi over 2 repeats every pi units. Okay, what does that mean? So if there's an asymptote at pi over 2, and it repeats every pi units, that'd be 2 pi over 2. So basically, every other one of our markers is going to be an asymptote. Okay, so what's going to kind of like show up in between them? How does that work? So here's the thing with those. The values in the middle, you'll notice when we said, hey, at 0, it's 0. And at pi, it's 0. And at 2 pi, it's 0. And if I went to the left, at negative pi, it was 0. What you're going to find is this. There are some smaller points in the middle. They're called quarter points. You're like, okay, so what the heck does that mean? So in between these two and here, you can kind of see a little bit. There's some that are a little raised more up, like the midway point between these. And so those quarter points, and I'm going to label them this first time. I'm not as concerned about the labeling as I am where the point's going to go. So I'm just going to kind of color these in a little darker. Because these, to be honest, we're more in guesstimation mode, even though we know the value, than we are making sure every single point is labeled. Those points, okay, your amplitude affects your quarter points. So here's what I mean. All of these graphs are going to be infinite, okay? Here, my amplitude is 1. There's no number in front of tangent. So at those quarter points, when I'm graphing this, your tangent values to the left are going to be -1. To the right are going to be +1. They're going to be whatever the amplitude is. Because these graphs, when we're doing them, are all going to look like these funky, they're almost going to look like cubes that you're graphing. They're not. And they go up to the right. So the only thing that'll look different when you're doing a tangent graph is if your amplitude changes, these quarter points are going to move. So like if this has 2 in front of it, it's going to be a 2. It's going to be a -2. And it would make that stretch out a little bit longer. Or if it was a half, you'd go to this point here. So my dot would be here and here, or here and here. We kind of measure that off. We'll see that. But that's all there is to a tangent graph. Reminding myself that it's only pi as far as the regular period goes. And also that we're kind of going up to the right with these as we go. That's where the one's a little bit different or tricky with this one. So as you can imagine, when you do cotangent, we're just going to flip everything. So let's see how this goes. The cycle moves. You're like, why the heck did the cycle just move? Because now if you think about it, if everything just swapped, all those places that were the asymptotes before are now going to be the points that you're going through with your x-axis. And all the places where you were going through the x-axis before have now become your asymptotes. Period is the same. It's still pi. But that pi now, if you're looking at your base graph, instead of being between negative and positive pi over 2, is now between 0 and pi. It moved. It shifted a little bit. And so the only other thing that's going to change is now, and I'll make note of this, the graphs face opposite directions. So now, instead of going up to the right, we're going to go down to the right. Still going to look at those quarter points, and since my A value is 1 this time, those quarter points, we're going to keep doing the same thing that we did before. Except, now we're going to be going down to the right. And again, don't worry if your graphs aren't perfect. I still mess these things up too. It happens. And down we go. Again, I'm not worried right now about you firing off exact values for quarter points and having negative pi over 4, negative 3 pi over 4, and smashing all those in and making everything a mess and getting confused. As long as you have the general idea that your amplitude is going to move that up or down, you're good. Okay? And that's all there is with these. All these infinite looking graphs that have no end. But that's it. We'll kind of play with that some more down the road. We're not worried. The last one, and this is why I wanted to do this section right away and not wait. The last piece is making the connection with your sine and cosine inverses. This one, it tends to click, and it's like, oh, so, okay, wait a minute. Cosecant, which one is that the inverse of? Sine. So, okay, so we're going to think sine of x. So if this was sine of x, we'd go through and we're like, okay, so sine is 0, 1, 0, -1, 0. We'll just start with those. We won't put the extras in yet. Don't connect them though, because we're going to use these points in a little different of a way. So here's how this is going to work. The x-intercepts of your sine are the asymptotes for cosecant. Oh, this is kind of weird. Okay. So the x-intercepts have become asymptotes. All right. So what about the other points that I see? The other points that you see are going to be mins and maxes of what look to be parabolas. My a value is 1, so that's why these were at 1 and -1. If it changes, those would. So that max just became the min of this. This min just became my max. And that's all there is to it. You're taking the sine graph that you hopefully already are getting acquainted with and know at this point, and just using it differently. You're using the max and the min to create the graph, and you're using the intercepts to create asymptotes. And that's it. That's all you're doing. So, when you're starting to do some of these, here's the other part to it. And you're kind of going to probably have an idea of how this works. Secant, you're like, let me guess, Hardy. Think cosine. Okay. I did my base cosine graph. Loved the idea of the water slide that I was given yesterday. So I'm like, all right. So we start at the top. Here we go. We're sliding down. We're sliding down. Whee! Now we start to come back up the ladder, and we get back to the top. The idea is going to be exactly the same as what we did before. The x-intercepts are my asymptotes. The mins and maxes that remain are going to end up, I'm going to put my other one in here so we can see this. My other mins and maxes that I see will be mins and maxes that I have for those. So again, just like sine and cosine, depending on the part you look, they can look really similar. Like those two, you're like, Hardy, how am I going to tell the difference? I see asymptotes and I see these things that look like parabolas everywhere. You're going to have to pay attention to where you're making your asymptotes. That's going to be the hint. That's how you're going to figure out which one's which when you're doing these. If your asymptotes are like at 0 and pi, you're in cosecant mode. If they're at the over 2's, you're in cosine mode. And so, the last couple of things I'm going to do, because I don't want to go crazy with these, and I don't want you digging so deep into these you forget about all the other stuff you've been working on. But I want to touch on a couple so you can see the slight differences in things. So like for instance, if we're playing with secant here, okay, the amplitude is different. Okay, the period is still not. I don't have a b value here, okay? My b value is 1, so my period is still 2 pi, just like it is on sine and cosine. That has not changed. So again, think about cosine. So you're like, all right, if the amplitude's 2, remember it's like 1, 0, negative 1, 0, 1. There's my base cosine, but I'm multiplying them all by 2. So 2, 0, negative 2, 0, positive 2. But don't connect them. Because again, this isn't a cosine graph, it's a secant graph. And so even if I decided, hey, what if I just ran this whole thing? So I'm like, all right, up and down, up. Everywhere you see an x-intercept is just an asymptote. And everywhere you see a max or a min, so what A does when you're dealing with secant and cosecant is it's going to move your max or your min higher or lower. You're not going to have all the quarter point stuff that you're going to worry about quite as much. We need it on the tangent, otherwise nothing changes. With these, the A value will take care of itself for us. And we're not going to have to do a whole lot. So, I believe, I'm just checking. Yep, those are the two twists I want to see. So the last twist, since tangent is new, I want to make sure that we get this. Because the other ones, everybody always tells me, well, that's easy. But then they get to these and they're like, don't like this. All right, amplitude is 2. Remember, with tangent, your period naturally is only pi, but you're still dividing it by b. 2 divided by a half, pi divided by a half, is the same thing as pi times 2, or now 2 pi. So, wait a minute, Hardy, so how does that work? Okay, when we did the tangent before, we said normally between negative pi over 2 and pi over 2, that'd be 1 pi. Well, this is double. So we're going to expand it by another pi over 2 each direction. So, if this is the norm, if it gets bigger, it's going to stretch out. If it got smaller, we'd squeeze it in a little bit when we're doing these. So I've got my asymptote set, because it doesn't go out wide enough for me to see more. So now again, reminder, and try to simplify things in your mind a bit. When we did the tangent over here, so you're like, so do I have to really remember, this whole chart and think about it? No, what you've got to think about is when you come to these, notice on every single one of these, your x-intercept was dabbed straight in the middle of those two asymptotes every time. Same thing's going to go on here. What's right in the middle of pi and negative pi? 0. Okay? If this went out to negative 3 pi and positive 3 pi, okay, and there were more asymptotes sitting here, what would be right in the middle of 1 and 3? 2. What's in the middle of negative 1 and negative 3? Negative 2. And the only other thing to play with, you're like, oh my gosh, those stupid quarter points. Those points that are right in the middle between my point and my asymptote. No matter how big they are. The amplitude is 2. So those quarter points, no matter where they're at, did I just put them up in the wrong direction? I did. Dadgummit, Hardy, I did a cotangent. I did cotangent instead of tangent. See, I even get going too fast sometimes and do silly stuff. I noticed it on the second one. I didn't notice it on the first. So as long as you have the basics, and on tangent and cotangent, knowing where those initial asymptotes are is probably as basic as it's going to get with this when you're trying to figure these out. And so to wrap up, you're like, hallelujah, Hardy, wrapping up. Oh boy, we're going to throw 2 twists at you. All right. Your amplitude. Now again, yes, the amplitude is a half because it's always positive. But remember, you're still going to multiply by negative 1/2 when you're doing your amplitude here, okay? So don't forget that piece. And so your period, this time, because there's my B value, is pi over 2. Ooh. So my period, bless you, is squishing in. So now, normally, on cotangent, we're between 0 and pi, but we just cut that in half. So now, instead of being at 0 and pi, you're like, Hardy, I don't even know what those points are. Oh, we're going to figure this out. Between 0 and 1/2 is 1/4. Because again, if you have to, get out of there. 1/2 divided by 2 is 1/4. Okay. 1/4, 2/4, 3/4. We've done this on other things. And so what you're going to end up with here since we smushed our period this time, the period's only going to be 1/2 pi in distance. You're like, okay, I know the middle point's going to be here on these. That's the part we're always good on. But now, oh boy, negative 1/2 for our amplitude. So normally, remember, cotangent is normally down to the right, but I'm multiplying it by a negative, so it's going to flip on us. It's going to look like a tangent graph. So that negative 1/2 is again going to be those quarter points, which is really going to smash this in. But it all comes back to the asymptotes again. And I know darn well we're going to have to talk about this again, whether it's next time I see you, after testing, no matter what it is. But sometime between then and now,